Live now.
Great. Thanks very much. Thanks everybody for joining. And this won't be as much of a presentation as it will me positing a question to you folks in the audience. The title of the quick slide talk that I'm going to give here to set the frame for the question: potential pitfalls protecting patient privacy. It comes a little bit from my role. I'm the head of quote unquote AI, whatever that means, for R&D information research at a company called AbbVie. We are a global biopharmaceutical company, so we carry a lot of the taboos of big pharma. And one of the interesting things that I found when I entered big pharma after working in big finance was that the R&D communities at these pharma companies, especially the one I work in, but almost universally the others I've talked to, everything is focused on the patients, on making an impact in the patients' lives and actually providing better, faster therapeutics and cures for patients and things like that. And so I don't want to fall into the trap of talking about the evils of big pharma, because we could, but that's a separate issue. What we want to talk about is, in the context of, again, I'll use air quotes, AI, how do we protect patient privacy? And I'm going to go through a very specific sort of scenario here. And I'm looking for the community. I'm looking for folks from the village and from otherwise to provide some feedback and their opinions. This is a problem we are not facing yet, but we will face going in the future. So we're actually trying to get ahead of the curve when it comes to patient privacy in this case. And the basic premises I'll lay out the problem for you as we go. So first off, what AI are we talking about here? AI is a crappy term. It's been destroyed by marketing and everything. So we're not talking about artificial general intelligence. In this case, we're talking about anything that falls in that AI bucket, but that is applied to the process of taking and connecting information to turn it into knowledge and comprehending that knowledge to extract insights. And so we're talking about a lot of predictive algorithms. We're talking about a lot of some generative algorithms and things like that, classification mechanisms. We're talking about traditional machine learning as well as deep learning tools. And how are they being applied in this context? The privacy angle comes about, well, let's start here. Data and information versus knowledge. So what does data and information look like? It's data, it's columns, it's rows, it's tables, it's things like that. Knowledge looks very different. And knowledge in this case, this is an example of the basic knowledge graph in our discovery scientific environment. And you can see there's a lot of solid lines that connect different concepts through this space where we have real data, where we have data and information about those relationships, tables and rows. In this case, we're working with tens to hundreds of petabytes of data and information that ultimately can be distilled down to this knowledge graph. And the key is these hashed lines. They become really important later. These are the inferences. These are these inferred associations that we're trying to be able to draw as new knowledge. And so at scale, it can look like this. These are just a few representations of some of the knowledge contained in the knowledge graph that we're working with inside our R&D community. And ultimately, some base premises on the problem. All of the patients that we're talking about are providing their information, including PHI, as part of participation in clinical trials. They are, that PHI is blinded or removed to prevent re-identification of the patient in the data and information that we're working with. And these patients are giving their consent for their data to be used for both specific endpoints and for secondary analysis and use. And these are all important concepts to lay out, because ultimately it's that patient's rights that we're trying to protect when we're talking about the consequence downstream of what we're doing. The data sets that are inclusive of that consented patient information are then connected and curated by scientists to build a knowledge graph. And we use AI methods to predict insights and infer new knowledge from that graph. What we're effectively doing is predicting missing edges in the graph. We're predicting property values in that graph. We're predicting classifications and things like that around the graph itself. And that new knowledge is then used by scientists to say, well, if there's a prediction that this compound or compounds like it should bind to this target gene, then let's go run an experiment to prove that. And so the knowledge graph grows as a process of inferences then being tested as hypotheses using the scientific method and assays in the lab and peer review of published work to eventually become new solid lines in that graph, where those dashed lines of inferences become solid lines of knowledge backed by data and curation of that data. Our challenge is this: what happens if a patient retracts their consent for use of their data, and does that cascade to knowledge and insights that were extracted or inferred from the data sets that include their data? So if I'm a clinical trial patient, I have the right to retract my consent for that data to be used at any point in time per whatever the consent agreements and everything that are reviewed and signed by patients as they choose to participate. And if they retract that consent, obviously the data that is gathered is covered by that consent, should be removed from our databases, should be removed from any of our data sources. But if we're using that data and we've trained an algorithm on it, do we have to retrain the algorithm? Or can the algorithm is what the algorithm has learned, is that subject to the retraction of consent? Because that algorithm was trained on that patient's data, does that algorithm need to be retrained when that patient retracts that consent? And when we think about predicted knowledge or predicted or extracted insights from that, what if that patient removing their data, what does it mean? What's the impact if removing that one patient's data causes that knowledge assertion to fall below a significance threshold? I.e., when I had that patient's data, I could assert that this gene, that this compound binds to this gene target, or that this gene target is associated with this disease condition, or something like that. Without that patient's data, if I can no longer statistically significantly make that assertion, what's the impact? What does that mean? Or what if I can still significantly impact that? What is the implication there? Does it imply that this patient's data is not necessary or not important to the calculation? Does it even change the significance thresholds? And this is, maybe a little of a basic side of the argument, but when we start to think about this in terms of what happens now with human beings, when I, as a human being, learn something by experience and exposure to data, I don't necessarily forget that. I can't forget that. It's like in a courtroom when the judge says the jury's ordered to disregard this. Okay, they can disregard it, but they can't use it in their justification, but they don't forget what they've heard. And so in the same thing, as humans, we don't forget what we've learned by looking at data even after that data is retracted. But with the persistence of knowledge in this graph, what does it mean to forget information in the graph? Do knowledge graphs need to decay over time to represent this in a way that's efficient? And then there's this impact of, what if that specific knowledge or insight that was extracted ultimately is the step that allows you to get to a therapeutic or cure with a significant positive impact on society, but by retracting that patient's retraction of consent, that knowledge falls away and you cannot make it to that cure or that impact. This is ultimately the impact on the many for the rights of the one in this case. So ultimately, the question I pose is, does the right to be forgotten, as it's expressed with regulations and protections around data, also extend to the derivative knowledge and insights that AI algorithms extract and infer? And how does patient privacy, which is reflected in these regulations, how does that flow from that? And I want to be clear too, there's both a legal question and a moral question. From a tactical perspective though, for folks like myself and my team, how do we ensure that we're doing not just what is legal, but what's right? And what is right for the patient or for the patients that are, the both prior and posterior in this case? How do we ensure we're driving towards that maximum positive impact for populations of people without sacrificing the rights of the individual? And how do we move in a general sense from assessing what we can do with this data and with this knowledge to what we should do? And this moral question is ultimately at the heart of why it matters. Our chief scientific officer, Tom Hudson, who's effectively the head of R&D, has said he wants us to engage in the process of sharing our knowledge. Well, tactically, tangibly, what that means is taking away anything that's considered the company's intellectual property, compound structures, for example. We should be able to publish this knowledge graph to the world and allow any researcher, any institution, anybody who wants to use that graph to do academic research. And that's based on this concept that if we believe that knowledge and insights from that graph have the potential to enable better, faster cures and therapies, and if we admit our own individual ability to be intelligent with this is limited by our capacity as human beings to work with the scale and scope of this data and this information in digital form. And if we believe that these AI algorithms have the potential to give us broader access to do those things, and if we believe that by sharing this knowledge, that others are able to bring in their own different points of view, and they may get to the important things that we don't or that we miss from our limited points of view, do we not have a moral obligation to share that knowledge? And does that moral obligation also extend to, once we know something, we shouldn't have to or should have to retract that from the public sphere? If we process data that includes a patient's consent, we generate this knowledge, and then we share that knowledge publicly, and then that patient retracts that consent. How does the moral obligation to share that knowledge that we at one point had with the rest of the world that might persist as, how does that flow through? And so this is the basis of the question that I am just here today, not to pose an answer, but to hopefully open discussion and open answer, find some answers and work towards answers with, the community of the village, the AI village, and anybody else who's interested. So I've put both my personal email address as well as my professional email address for those of you who don't feel comfortable communicating directly with the corporate address. I'm not here representing AbbVie. I'm representing this challenge in an agnostic way that we're all going to try and have to find a way through as the data science, the AI approach starts to engage more and more working with derivative knowledge than just data. And so with that brief presentation, I kind of open it up to the audience. I'd love to have questions or comments, anything I'd talk about, be happy to talk about with folks.
Thank you very much for that. There's a couple questions coming in on Discord. So how would, if I built a model that was differentially private, so in some sense,
Sure. Yeah, sure. There we go. I'll stop my video here too.
Oh, okay. Start your video again. There we go.
All right. There we go.
It looked all good. Anyway, so if you had a model knowledge graph that was derived from a differentially private model. Would you feel a lot more okay with like, it's essentially it's memorized nothing from any individual person.
Sure. And you know, one of the questions is, if I took all of the data, right, and I'm doing some sort of cross-fold validation where I'm removing chunks of the data set, and if I get consistent training across those where I have pulled out subsets of the data, when I'm just training that initial model, does that not present the differential privacy question? Yeah. Can you say that a model is trained, if the model is trained only on the training data, and I train that model iteratively, and I keep flipping individual patients' data out of the training set, and I still get to my achieved output, is it trained on that user's data, or can it be effectively believed to be trained on the aggregate of the user's data, but no individual user's data, sufficiently of a fashion that I no longer need to retrain that model? I can use it as is, delete the patient's data based on their consent, and find that I am both legally and morally in alignment with the intent of that right to be forgotten.
But then there's the other side of the coin, which you were getting at, is like, if you have a rare disease, that's definitely in the tail of the distribution. There might only be 100 people on the planet with this disease. Your machine learning model definitely learned about it from one of those people, and that could, removing them could easily destroy the knowledge, the advantages that it generated.
Yeah, and one of the biggest challenges that we face, and part of the reason that you're going to see a lot of companies like ours and others try and find how to get data from healthy people, right? How to have healthy people be willing to consent to their use of their data. Because if all I have are clinical trial participants in a Parkinson's trial, they all have some form of mild cognitive impairment, or they wouldn't even be going to a Parkinson's clinical trial, right? But we don't have sort of the balancing of that data set with healthy patients to really say, so when I say this algorithm predicts something like Parkinson's, or predicts progression of Parkinson's disease, progression of cognitive impairment, I'm biasing that on people who are already into that pipeline, as opposed to taking into account those people who may not have any of the indicators yet, or may not have a diagnosis yet. So there's an inevitable part of that especially for rare diseases, means your algorithm is highly biased towards those specific patients. And if I remove 1 out of 20 patients, 1/20th of my data, how is that going to play? Now, the realistic fact is that I don't need an AI algorithm when I only have a data set of 20 patients. The only place where I really need these algorithms is where the scale and scope and complexity of the patient data that's coming in is such that a human being can't process it, can't grasp the full scope in the wetware and manage to make statistically significant assertions through that. So there's a little bit of we wouldn't see it in this context anyways, perhaps.
So Coldwater from Discord has a question basically around how. So in security, our models have a lot of turnover. Every month we retrain and redeploy. If we deleted a data point, it would just not be included in next month's model. Would that be a means of like right to be forgotten, where you just naturally get removed in the turnover?
It's an interesting question, because when you're dealing with a fluid and transactional data set, absolutely. So for financial algorithms, things that I'd done in the past before I came to AbbVie, that was generally the approach we would take, right? You would allow time windowing to allow things like that to go through. Here, if I've run a high throughput screening test on a compound and whether it binds to a gene, or if I have data from a patient that was, this patient was administered this compound at this dosage, and here's how their, measured health conditions went over time, I don't have that high transactional throughput rate that I could say, okay, well, just ignore that patient moving forward. what we're talking about from this knowledge graph is not a point in time representation of knowledge. It is an aggregate representation of knowledge. Ultimately, it is if I take all of the data and I apply all of the knowledge curation skill of a set of scientists and data scientists, and I distill from all of that data through that curation process into a set of knowledge, what do I have? What I have is the aggregate knowledge of all of those scientists as applied to all of that data. That's a different perspective than if I take a set of data from a period of time and that time window slips, and I'm looking at that knowledge representation as a point in time. Here is the knowledge of our security folks as applied to that data to generate a graph. The graph goes with the time windowing of that.
Well, we got another question coming in, but I just wanted to say I worked at Johns Hopkins in the ML systems, and we definitely had a problem getting enough healthy data. And for one of the things, like when people started having heart attacks, they got rushed to the EKG, rushed to the cardiology department, and our EKGs got cut off. Yeah. So it is data set collection in healthcare is very hard. So Mariana Me has a question. How often is consent to use data retracted? Perhaps the consent would be more binding if when using ML models.
So that's a very interesting question. Historically, it's never been retracted, right? Patients really, they go into a trial, they don't go in and then retract their consent later. But historically, secondary use of data was not necessarily part of their consent. When you signed a consent form, that consent said the information and data collected will be used for this trial, for this purpose, for these specific endpoints as they are defined in the clinical trials protocol. It's only recently that, because of the advent of, man, it would be great if we could connect clinical data to genomics data, to assay data, to all these different things, that the idea that we have to ask the patients for secondary use rights as part of consent has come into play. And so while historically consent has not been withdrawn, as we are asking patients for more license to use their data, the ability for them to retract that consent goes along with it. And regulatory, if we think about GDPR and we think about some of the implications of that, there are both internal and external retraction of consent that inherently now exist. And even if we still, because I don't have any numbers, still don't know how many would retract, we need to be prepared in case they do. And we want to make sure that we're approaching things from the start with a proper both legal and moral perspective on the rights of the patient. They have been willing to give us this data to work with. It's our moral obligation to treat that as sacrosanct and to treat that data as their asset that has been entrusted to us with license to use in an appropriate fashion.
Yeah. So I have a bit of a follow-up question to that. So correct me if I'm wrong, but I was under the impression that the right to be forgotten comes from laws about search in Germany. It's boiled down from there and has come into the healthcare debate. But that has more to do with your public image. And in this case, your personal data isn't publicly available. It's been filtered through several layers of research, and you're still anonymized in this data set. Does this moral obligation even apply here, or is it a bit of a misplaced thing?
That's exactly part of the question that nobody, at this point, there isn't legal precedent to clearly give us answers to this. So we're operating in this null space of, we don't think it should apply, but if we do something and we violate that, if somebody comes and engages in some type of legal action and we're found to be in violation of it, then what do we do? And so it's the catch-22 of, we may not know until someone actually contests it legally, we want to make sure, from the data scientist perspective, I don't want to have to sit in a conference room with our legal folks and explain why we never thought, never engaged in the conversation about whether it was okay or whether it's something we should do, as opposed to, yeah, it's something we can do. And we thought it would be okay because our interpretation of this, blah, blah, blah. And our legal folks are like, well, we don't understand necessarily what even you're working about talking with here. So it's this nebulous sort of space where it's gray area. And that is honestly why I'm here kind of asking the question of you folks, like, what do you think as people who are experts and constantly thinking about privacy and about security? How do you feel about it? How do you think about this problem?
I mean, me personally, I avoided this part of the debate by going into a security thing and dealing with malware models, where a malware author has no right to be forgotten because they essentially like spewed malware on the internet and it's there forever, and we downloaded it and I have a training thing, and there's no real privacy. We filter our data so very well. And there's no real like expectation of privacy on their part because they're bad guys, in some sense. But there are other people involved who have a lot of interest in this and are in the village, who have a lot of experience with this particular thing and have these difficult questions at work. So I hope this discussion continues.
Yeah. And I don't know if it's easy to put up on the screen or not, but anybody listening, my email address, I'm encouraging folks who have points of view, who have interest in this, to reach out, to open the discussion. I'm on the Discord thing for the AI Village now as Brian M1028. Please feel free to reach out to me there, as well as at my email, bsm@uchicago.edu. Or to my corporate email address as well, if you prefer.
Well, thank you very much. I'm going to get set up for the next talk right now, and then the Twitter one after that.
Thanks so much, folks. Everybody take care and be healthy.
Cool. Have fun.